Hi, I'm Chris Teutsch, Forage Extension Specialist at the University of Kentucky's Research and Education Center located in Princeton, Kentucky. And the title of my poster today is Impact of Fertilizer Type, Seed Coating, and Duration of Exposure on the Germination of Orchardgrass Seed. I'd like to draw attention to my co-authors, Lindsay Sparks. Lindsay is an undergraduate student from the University of Tennessee who was an intern here at the research station this summer, and my colleague, Edwin Ritchey, who's a soil scientist here at the research station in Princeton. As everyone knows, cool season grasses are an important part of grassland ecosystems here in the transition zone. In order for pastures to be productive and sustainable, they need to be healthy and vigorous, and this is often accomplished by overseeding pastures with a mixture of seed and often mixed with fertilizer, and we do this in late winter or early spring. The objective of the current study was to evaluate the impact of fertilizer type and the duration of exposure on the germination of raw and coated orchardgrass seed. Our experimental design was a random complete block with 4 replications. We had 2 fertilizer treatments. We had muriate of potash, and we chose muriate of potash because it has a very high salt index. So our hypothesis is that it would cause more injury in the seed than a fertilizer combination with lower salt index. Our second type of fertilizer was a blended fertilizer, a 19-19-19. This is what a lot of farmers would commonly apply in the spring to pastures. So we mixed either raw or coated orchardgrass seed with those 2 different types of fertilizer for 0 to 28 days. And then we stored those mixtures in a tobacco barn under ambient temperature and humidity conditions. Once the time period was up, we germinated the seed in the Petri dishes, and we did counts of the orchard grass at 7, 10, and 14 days after we placed it in the Petri dishes. We analyzed the data using regression analysis, and we used a program called SigmaPlot 14.0 to generate our graphs and conduct our statistical analysis. I'd like to take a minute and just show you the results of our study. And the way this graphs are set up, we have got figure 1, and figure 1 is the impact of fertilizer type and duration on the exposure of germination of raw and coated orchardgrass seed. And this is the first trial, and then figure 2 is the second trial. On the left-hand side is orchard grass that was exposed to potash fertilizer or the muriate of potash. On the right-hand side is the same seed but exposed to the blended fertilizer for 0 to 28 days. Same setup for figure 2, but that was a second trial. So just a couple things to note is that the muriate of potash resulted in a linear decline in seed germination. So if we look here, this is the linear decline that we're seeing. In both the coated seed and the uncoated seed declined at the same rate. So we didn't see an effect of coating for the muriate of potash. Now, when we look at the blended fertilizer, what we can see is that they result in a quadratic decrease in germination of the seed. And that decrease was different for the raw and the coated seed. The coated seed declined at a faster rate than the raw seed. One thing to note about the blended fertilizer was when we placed it under ambient environmental conditions in a tobacco barn, so it was protected from rain, but the humidity and the temperature were the same as the outside of the tobacco barn. When we did that, the blended fertilizer picked up a lot more moisture. So it was almost like a slurry by the end of the 28 days. And we think that that had a major impact on salt injury in that seed because that moisture that it picked up was allowing that salt to actually be imbibed into the seed or absorbed into the seed, and that was causing a decrease in germination. The other interesting part that we observed was that the seed coating is designed to be hygroscopic. So what that means is it's designed to attract water, and that's good when the seed's trying to germinate in the soil because if there's limited moisture, it will help draw moisture into the seed. Now, when it's exposed to the fertilizer, that's not so good because it's causing that salty solution to be absorbed into the seed at a greater rate. And that's why we saw differences in the rate of germination decline between coated seed, the bottom line on both graphs, and uncoated or raw seed. So if you have any questions on this, my contact information is at the bottom of this poster, and you're more than welcome to give me a call or shoot me an email. We also have a second poster, and it looks at the impact of fertilizer type, seed coating, and duration of exposure on the germination of red clover seed. Thank you for taking the time to take a look at our poster, and please feel free to contact me with any questions.